Math 2, Unit 8, Worksheet 4. Express in simplest radical form all variables representing positive numbers. Alright, so from last semester, remember when we were going to do the square root, or we're going to take the root of something, we want to break it down to its smallest parts. So 20 is 2 times 10, and 10 is 2 times 5. And since this is square root, we know we need 2 to get 1 out, so 1 gets out, the other gets killed, so the 5 stays inside because it doesn't have a pair, so we have 2 root 5. Alright, so the square root of 63 is really the square root of 6 times 9, and I'm sorry, no it's not, it's 7 times 9, and the square root of 63 becomes 7 times 3 times 3. 1 3 gets out, 1 3 gets killed, and the 7 stays in, so this becomes 3 root 7. Number 3, the square root of 50 m to the third n becomes 50 is 2 times 25, which is 5 times 5. We have 3 m's and 1 n, so the 2 stays inside because it doesn't have a partner. 2 5's, 1 gets out, 1 gets killed. 2 m's, 1 gets out, 1 gets killed. This guy's stuck inside without a partner, just like the n. So we have a 5 and an m getting out, which is 5m. What's left inside? A 2mn. Alright, the square root of 72. Well, 72 is 2 times 36. 36 is 6 times 6. And we have, I'm going to break this up. Instead of 4 a's, I'm going to say this is a squared times a squared. And b to the 6 is really b squared times b squared times b squared. Alright, so this becomes the square root of, well, a 6 gets out, a 6 gets killed. So we have a 6 on the outside. The 2 stuck in, so I'm going to leave him in there. Alright, well, if you have a squared, that means there's a pair, so 1 gets out, 1 gets killed. And here you have a pair, so 1 gets out, 1 gets killed. Okay, b squared, again, 1 gets out, 1 gets killed, 1 gets out, 1 gets killed, 1 gets out, 1 gets killed. So what we end up with is 6, a squared, b to the third, square root 2. Alright, moving on. This is the square root of 225k to the fifth, so square root 225 is 15 times 15. Alright, now I'm going to leave it like that. So we have a pair, so 1 gets out, 1 gets killed. So a very helpful way, since this is square root, a very helpful way of doing variables is if we think of how many 2's are there in k to the fifth? Well, there's 2 2's. Alright, so how many times does 2 go into 5? It goes in twice, which means we get 2 k's out. Well, how many are left over? Just 1, so we end up with the square root of k. Alright, now this is square root, so we have 5 times the square root of 160 is 2 times 80, 80 is 2 times 40, 40 is 2 times 20, 20 is 2 times 10, and 10 is 2 times 5. And we could say, so let's start with the 2's. So we have a pair of 2's, 1 gets out, 1 gets killed, 1 gets out, 1 gets killed. The 2 and the 5 are staying in because they're singletons. So we have 2 times 2 getting out are 4, and 4 times 5 is 20. Alright, we took care of the numbers. Now, how many times does 2 go into 8? It goes in 4 times, so it means 4 m's are getting out. There's no leftovers. What's left inside? A 2 times 5 or a 10. Alright. So now we got to be careful. We have the cubed root, which means it takes 3 to get 1 out. So I'm going to break this down. 40 is 2 times 20, which is 2 times 10, which is 2 times 5. And I'm going to leave that d to the 8th. So it takes 3 to get 1 out. So 1, 2 is getting out. The other 2 are getting killed. The 5 is staying in. Now how many 3s are there in 8? There are 2. So that means 2 d's are getting out. How many are left over? 2. So we have the square root of 5. And we had basically 3 goes into 8 twice, so 2 d's get out, and there's 2 left over, so we're left with a d squared on the inside. All right, moving on, we have the third root of 500m to the third. Well, let's break this up. We have 5 times 100, and 100 is 5 times 20, and 20 is 5 times 4. And we have 3 m's. Well, it takes 3 this time to get 1 out, so we have 3 5s, 1 gets out, 2 gets killed. The 4 stuck inside. We have 3 m's, 1 gets out, 2 gets killed. So what's left inside? Just the 4, so 5m square root 4. Alright, moving on, 216. So we have the third root of 216. Well, 216 is 2 times 108. 108 is 2 times 54. 54 is 2 times 27. And 27 is 3 times 3 times 3. Well, it takes 3 to get just 1 out, so 1 gets out, 2 get killed. 1 gets out, 2 gets killed, so we have a 2 and a 3 on the outside. Alright, now that's 6. And how many times is 3 going to 9? It goes in 3 times, so 3 a's gets out, there's no leftovers. How many times is 3 going to 7? It goes in twice, so 2 b's gets out with 1 left over. How many times is 3 going to 5? It goes in once with 2 left over. So to simplify this, we have 6a to the third b squared c square root bc squared. Alright, when we multiply square roots or any roots, if they're the same root, we can multiply them, and we basically put them both under the same roof. So square root 12 times square root 30 is just the square root of 12 times 30. I don't multiply them together because I'm going to end up breaking them up anyways. So 12 is 2 times 2 times 3. 30 is 3 times 10, or 3 times 2 times 5. So again, we're looking for pairs. So it looks like a 2 is getting out and a 2 is getting killed. A 3 is getting out and a 3 is getting killed, and this 2 and 5 stay in. 2 times 3 is 6, square root 10. Alright, when we multiply radicals with coefficients, we just multiply what's out in front, or 3 times 2 is 12, and then it's 5 and 8 go inside, and we have 12 square root 5 times 2 times 2 times 2. A 2 gets out, a 2 gets killed, the 5 and the 2 stay in. So when the 2 gets out, it multiplies. We get 24 times the square root of 5 times 2, or 10. Alright, now we have 7 times 1, so we get 7. And if we want to be smart about how we break this up, you don't have to break it up to its smallest part. I know that 48 is 3 times 16, and I know 16 is 4 times 4. So that's what 48 equals. And 27 is 3 times 3 times 3. So be smart about how you break things up. A 4 gets out, a 4 gets killed. A 3 gets out, a 3 gets killed. Another 3 gets out, and we end up with 4 times 3, which is 12, and 12 times 3 is 36. Alright, when we're adding or multiplying exponents, first of all, when we're multiplying radicals, everything goes in the same. So that means we have the square root. Now let's be smart. We have 4, and 8 is 4 times 2. So I'm going to leave it like that. And we have x to the first times x to the third is x to the fourth. Well, let's break that up into x squared times x squared. So 1 gets out, 1 gets killed, the 2 stays in. We have a pair of x squareds, 1 gets out, 1 gets killed. So we have 4x squared. What's left inside? Just the 2. Alright, we have 12 times 1, or 12. And what do we have over here? We have 21, which is 3 times 7, and 56, which is 7 times 8. Alright, and we have a, 2 plus 3 is a to the 5th, 5 plus 3 is b to the 8th. Alright, so right away I have the 12 on the outside, and I'll do this quite a bit. I'll just put that guy over there. So I have a 7 getting out and a 7 getting killed. The 3 is stuck inside. And this 8 I know is 2 times 2 times 2. 1 gets out, 1 gets killed, and that 2 is staying in. So a 2 is getting out, and I know that 2 is staying in. I've taken care of all the numbers now. So a to the 5th. How many times will 2 go into a to the 5th? A will go in, or 2 will go into 5 twice, so that means I'm getting 2 a's out with 1 left over. How many times will 2 go into 8? It'll go in 4 times, which means 4 b's are getting out. So if we clean this up, let's see, 12 times 7 is 84. 84 times 2 is 168. A squared b to the 4th. And what's left inside, we have 3 times 2 is 6a. Alright, now when we're adding radicals, we can only add identical radicals. Square root 3 plus square root 3 is simply 2 root 3. It's like combining like terms. Number 16, square root 5 plus 6 root 5 is 7 root 5. Before we can add these two, we have to simplify it. So we have 2 root 7 plus, well, 63 is basically 3 times 3 times 7. A 3 gets out, a 3 gets killed, and the 7 stays in, so we have 3 root 7. So 2 root 7 plus 3 root 7 is 5 root 7. Alright, so 12 is 2 times 2 times 3, so 2 root 3. Alright, 48 I already said is 4 times 4 times 3, so this becomes 4 root 3. 1 gets out, 1 gets killed, the 3's in, which means we have 6 root 3. So always simplify your radicals before you try and add. Alright, now you can break this down to all its parts, or you can, if you know your numbers pretty well, I know that 72 is 36 times 2. Square root of 36 is 6, so we have 6 root 2 minus 50 is 25 times 2, and I know the square root of 25 is 5, so we have 5 root 2 plus 7 root 2. 6 minus 5 is 1. 1 plus 7 is 8 root 2. Alright, so when we're adding or subtracting binomials, the first one we don't have to change. That's negative 9 plus 5 root 3. Here we have to distribute that negative sign, so negative 1 times 4 is negative 4. Negative 1 times 7 root 3 is negative 7 root 3. Now we just combine like terms. Negative 9 plus negative 4 is negative 13. 5 root 3 plus negative 7 root 3 is negative 2 root 3. Alright, here we're adding, so we don't have to distribute any negatives, so we just can pretend those parentheses aren't there. So it's simply 5 plus negative 7 is negative 2. Negative 3 root 7 plus 8 root 7 is 5 root 7. Alright, moving on. Rationalize and simplify each expression. So this is as simple as it gets, but remember we're not allowed to leave a irrational in the denominator, so we rationalize it by multiplying top and bottom by the square root of 3. 1 times the square root of 3 is just the square root of 3. Square root of 3 times square root of 3 is 3. Anytime you multiply two identical radicals, you just get what's underneath. Number 23, square root 5, multiply top and bottom by square root 5. We end up with 2 times square root 5, or 2 root 5. Square root 5 times square root 5 is simply 5. All right. This one we can simplify a little bit before we rationalize the denominator. We can put them under the same roof and we get 14 over 7. Now we can reduce and we just get the square root of 2. Do the same thing here. We get the square root of 20 over 15, which reduces to the square root of 4 over 3. Now we can simplify that, and we can say the square root of 4 over the square root of 3, which is 2 over the square root of 3. When we rationalize the denominator, we end up with 2 root 3 over 3. Alright, this one will separate to the square root of 3 over the square root of 4, which is just the square root of 3 over 2. Same thing here, we'll separate this to the square root of 25 over the square root of 6, which is 5 over the square root of 6. We have to rationalize the denominator by multiplying top and bottom by square root of 6, and we get 5 root 6 over 6. Alright, number 28. We will separate that to, well, no, we won't. Before we do that, we'll reduce to the square root of 1/9. And now we can separate it to the square root of 1 over the square root of 9, which is just 1/3. Alright, so this becomes as simple as it gets, so we will multiply top and bottom by the square root of 5 to rationalize the denominator. So the square root of 14 times the square root of 5 is the square root of 70. I know that can't be simplified because it's 2 times 7 times 5. There's no pairs in there. And square root of 5 times square root of 5 is 5, and 5 times 2 is 10. Alright, so this one we could simply multiply top and bottom by the square root of 5. And this becomes the square root of 15 times 5, or 3 times 5 times 5. So obviously on top a 5 gets out and a 3 stays in. On the bottom, square root of 5 times square root of 5 is 5, and 5 times 9 is 45. And you can see here we can reduce. 5 goes into 1, 5 goes into 5 once, and 5 goes into 45 9 times. So our final answer is square root 3 over 9.